Bismillah, Alhamdulillah, Assalatu wassalamu ala Rasulillah, Sallallahu alayhi wasallam, wa ala alihi wa ashabihi ajma'in. Allahumma salli wa sallim wa barik ala Nabiyyana Muhammad, Sallallahu alayhi wasallam. Assalamu alaikum. I would like to welcome all of you in this symposium. And the title of my keynote presentation is Sustainability in Engineering Education, a Washington Accord Roadmap for the SDG Era. I'm Professor Mazharul, Director, Center for Extension Services, AUST. Now, just to show you the outline of today's keynote speech, in the beginning, I'll have a kind of brief introduction about sustainability from engineering education perspective. Then I'll focus on International Engineering Alliance's GAPC. GAPC means Graduate Attributes and Professional Competencies, version 4, and sustainability. So today we'll be talking a lot about Washington Accord. So the latest GAPC is version 4, and I will be focusing on that as well. Then I'll try to suggest some notable enabling approaches to teaching sustainability based on research findings and scholarly sources, inshallah. And then finally, there will be call to action. Now, to start with the introduction, before I delve into the details of today's topics, I would like to give you a very quick snapshot or kind of global timeline about key sustainability related milestones. Yeah. And I would like to, recall the contribution of the Brundtland report came out in the year 1987. That was a groundbreaking work from the UN side. And this report defined sustainable development and introduced in modern era, the idea of meeting present needs without compromising future generations. Then also, I would like to highlight a kind of business approach, the triple bottom line approach proposed by John Elkington in 1994, where he focused on people, planet, profit, emphasizing the sustainable strategies in delivering values in social, environmental, and economic dimensions. Also, the global action came in the year 2015 in UN 2030 agenda, and they introduced the 17 SDGs, Sustainable Development Goals. And we'll be talking about a lot, about this SDGs a lot in today's presentation, inshallah. And then in the year 2018, World Federation of Engineering Organizations, they had their Engineering 2030 plan, and they focused on sustainability. Then in the year 2021, UNESCO had its engineering report where they focused on sustainability. Yeah, focused on sustainability and the SDGs. And finally, IEA, International Engineering Alliance's GAPC version 4 came out in the year 2021 in collaboration with WFEO and UNESCO. Yeah, they had their contributions as well. Then it came. So just to give you an idea how this GAPC version 4 came into picture. Okay, now starting with this definition of sustainability, I've taken it from UN Sustainable Development Solutions Network. So according to them, sustainability is a dynamic process of change towards a society that meets the needs of all while protecting the environment and promoting social equity. It requires the integration of economic, social, and environmental considerations in decision-making at all levels. So over and over again, we'll see these three pillars of sustainable development or sustainability: the economic dimension, the social dimension, and the environmental dimensions. Next, the 17 SDGs. I think all of us, we are familiar with the 17 SDGs. Yeah, they are kind of encompassing all aspects of development activities. Yeah, it's quite comprehensive. The 17 SDGs are quite comprehensive, touching different things in our life. For example, this higher education is with SDG 4, right? Quality education. So engineering drives progress across all 17 SDGs by creating solutions that are technically robust, socially inclusive, and environmentally sustainable. Now, if we divide these SDGs under different clusters, then you can see there are certain SDGs which are related to basic needs and well-being. And of course, there are options for engineering. Engineers, they have roles to play. Also, infrastructure, energy, innovation. You can see SDGs 4, 2, 4, 6, 7, 8, 9, 11. We have certain SDGs related to planet and natural resources. We have certain SDGs related to equity, justice, and governance. And also, SDG 7 is more specific about global partnership. So in all these areas, the key message is that engineers can play a kind of pivotal role. Yeah, pivotal role in all these SDGs through their development activities. Now, if we think about Bangladesh, the SDGs, the Washington Graduate Attributes, GAPC stress a lot about solving complex engineering problems with societal and environmental considerations. So to contribute effectively, engineering students must be aware of national SDG-related indicators. This is very important. Yeah, we see people are saying that we are implementing SDG, but it should be clear to them whether it's aligned with the national initiatives or not. So Bangladesh has this so-called 39+1 indicators, which is outlining different national priority targets. Yeah. So just to show you the Bangladesh perspective. So Bangladesh, for 17 SDGs, they have their priorities and it is monitored. In fact, it is reported to the UN. So for each SDG, we have certain targets which should be measurable, So it is very important that our engineering faculties, they introduce this for Bangladeshi students, these targets to the students. It's very critical. Okay, so you can, these slides will be shared inshallah later on. You can visit this important link yourself inshallah. Now, why teach sustainability in engineering programs? Yeah, the first and foremost would be accreditation. Today's world, without accreditation, it will become difficult for an engineering program to thrive. So accreditation is critical. And the GAPC version 4 is basically the Washington Accord. They want, this is a mandatory thing, which I'll show in my presentation. Also, renowned bodies like ABET from the US or BITE from Bangladesh. For them, sustainability is important as well, which are based on this GAPC version 4. Now, also, some of the global ranking systems nowadays, they are focusing on sustainability as well, like US World University Ranking. In that, 5% weight is for sustainability. And also we have the impact rankings, UI Green Metric, all of these things. And also, it will give us this sustainability teaching related activities. It will give us competitive edge. So it will supposed to enhance reputation of the institutions, attract partnerships, improves graduate employability, and aligns with the UN 2030 agenda. Okay, so the key message I want to deliver is this, that sustainability is now a must-have in engineering curricula, shaping accreditation, rankings, and graduate success. Now to move to GAPC 4. GAPC4 is has some key elements like this knowledge and attitude profiles, WK1 to 9, complex engineering problem solving ranges, WP1 to 7, complex engineering activities, EA1 to EA5, graduate attributes, WA1 to 11. Yeah. So I'll try to highlight these elements and show you how sustainability is very much embedded in these elements. So this IEA, just to tell you a few things about IEA, International Engineering Alliance. It's a global not-for-profit organization that governs mutual recognition agreements for engineering education and professional competence, promotes quality assurance and mobility of engineers worldwide, and oversees 3 key accords: Washington, Sydney, and Dublin. So these are for professional engineer, technologists, and technicians. So Washington Accord is related to professional engineers and relevant for us mainly. So that's our focus here. And Washington Accord, it was established in the year 1989, focuses on academic programs for professional engineers, and signatories recognize the equivalence of accredited engineering programs. And also they emphasizes graduate attributes and professional competencies for complex engineering problem solving. Yeah. And they're very much aligned with the latest version is very much aligned with the SDGs, which I'll show you, inshallah. So what is this GAPC version 3? Yeah. It is basically a document from IEA, and it serves as a basis for mutual recognition agreements. This GAPC, Graduate Attribute and Professional Competencies, version 4. So it was published with extensive inputs from World Federation of Engineering Organizations and UNESCO, aligning with global sustainability and SDG goals, and provides outcome-based benchmarks for knowledge profiles, complex engineering problem solving, complex engineering activities, and graduate attributes. And it's really a catalyst for curriculum reform. For your kind information, BIET, which is the accreditation agency in Bangladesh, they have adopted GAPC4 in their latest manual, version 3. So in version 3, they have adopted this GAPC4. In GAPC4, there are 11 graduate attributes. They have added an extra one related to entrepreneurship. But anyway, they have adopted this as well. So it has some implications, this GAPC4. So the implications for engineering educators would be they need to integrate sustainability holistically across all levels of the curriculum, not as an isolated module. So leverage WA graduate attributes and knowledge profiles to assess competencies aligned with the SDGs, and prioritize ethical reasoning, ecological awareness, and social responsibility as core learning outcomes, and design open-ended interdisciplinary projects that align with the sustainability vision of GAPC4. So just to quickly tell you about these different elements of GAPC, starting with knowledge and attitude profile, WK1 to 9. So there are 9 knowledge profiles, WK1 to 9. 2 of them are directly related to sustainable development, WK5 and WK7. WK5 is sustainable design and operations, and WK7 is societal role and responsibility. So I'll show you shortly that how they are related. So starting with WK5, they are basically knowledge supporting sustainable energy design. WK5 is a must for the design-related PO or graduate attributes. So it's very important, and this is in this WK, it's explicitly written that there should be knowledge, including efficient resource use, environmental impacts, whole life cost, so life cycle cost assessment, reuse of resources, net zero carbon, and similar concepts that support engineering design and operation in practice area. Okay, so it's clearly mentioning these aspects. So what are the implications from engineering education perspective? So we need to integrate life cycle assessment and carbon footprinting in core and elective courses. Apply sustainability metrics related to energy emissions and resource use in all major design projects. Use real-world case studies to connect theoretical concepts with engineering practice. Encourage innovation for net zero and circular economy. And also foster interdisciplinary collaboration, linking engineering with economics, policy, and social sciences. So this knowledge profile is very critical for upholding sustainability. The next one, WK7, it's basically related to professional practice. So here, if I read it out, so knowledge of the role of engineering in society and identify issues in engineering practice in the discipline, such as professional responsibility of an engineer of public safety and sustainable development. So here, explicitly sustainable development is mentioned. You can see in this knowledge profile. So what are the implications for each one? I'll try to show you the implications. Implications will be, we need to embed engineering ethics and professional responsibility in curriculum. We need to integrate sustainable development principles, use case studies on public safety failures and successes, encourage stakeholder engagement, link technical solutions to social, environmental, and economic outcomes, 3 pillars of sustainability. Also, foster awareness of global challenges such as climate change, resource scarcity, and infrastructure resilience. So you can see how this WK7 is critical in promoting sustainability. Now, if we look into the complex engineering problem-solving ranges, then there are 7. Of course, all of them can address sustainability, but I would like to emphasize more on WP2, which is related to range of conflicting resources involving wide-ranging and or conflicting technical and non-technical issues. Okay, so here in this range of complex engineering problem solving, you can see the issue of sustainability is explicitly mentioned. Even the economic, societal, all these things are also mentioned here clearly. So the implications will be that the projects with explicit trade-off analysis across technical, non-technical factors include ethical, legal, political, sustainability constraints in problem framing, teach multi-criteria decision-making for conflicting requirements, scenario-based work addressing future societal technologies or needs, interdisciplinary teamwork on complex multidimensional problems, and real-world case studies. So these are needed in order to address this particular range of complex engineering problem solving. Next, if we go to complex engineering activities, there are 5 in GAPC 4. I would like to focus on EA4, this 4th range, which is consequences to society and the environment. These are 2 pillars of sustainability. Yeah. So this is really quite critical for teaching sustainability for our engineering students. So implications would be, we need to embed risk assessments and safety cases in design studios, teach uncertainty quantification, sensitivity analysis, scenario planning, requires EIA, SIA, environmental impact assessment, social impact assessment, and stakeholder engagement for projects with societal and environmental impacts. Apply precautionary alert principles designed for mitigation and containment, develop resilience and fail-safe or fail operational strategies for low probability, high impact events, and also plan monitoring, contingency, and emergency response with clear triggers and metrics. And finally, I want to highlight how sustainability are embedded in graduate attributes. There are 11 graduate attributes defined in GAPC 4. Of course, all of them can address SDGs, but I would like to focus particularly on 3 of them: WA2, WA3, and WA6. Starting with WA2, which is related to problem analysis. Here you can see that this one is explicitly talking about sustainable development in the statement, explicitly talking about sustainable development, and there is an asterisk, which it means that represented by 17 UN Sustainable Development Goals, UN SDGs. So it is very much there in the second graduate attribute of GAPC 4. So the implications for engineering education would be, we need to embed literature review and evidence-based analysis in assignments and projects. Also, apply first principles for mathematics and natural sciences and engineering sciences in problem solving. Integrate sustainability considerations in all the 3 dimensions, environmental, social, and economic, in the analysis stage. Also encourage multi-perspective evaluation of solutions, including ethical and societal dimensions. And it's very critical that we use case studies whenever possible, where rigorous analysis lead to innovative, sustainable solutions. The next graduate attribute, which is quite critical for teaching sustainability, is WA3, design and development of solutions. Earlier I discussed about WK5. I've seen that and that WK5 must be addressed in this WA3. Yeah, and here you can see in this graduate attribute that our students should be able to design creative solutions for complex engineering problems and design systems, components of processes to meet identified needs with appropriate consideration for public health and safety. So this is public health and safety, the social dimension, the whole life cost, the life cycle assessment, net zero carbon, as well as resource, cultural, societal, environmental considerations as required. So this graduate attribute mandates that we incorporate design projects addressing real-world complex problems with multi-criteria requirements. Require consideration for public health and safety in all design briefs. Integrate whole life cycle cost analysis and net zero carbon strategies into design methodology. Address resource efficiency, cultural relevance, societal needs, and environmental stewardship in solutions, and use iterative design processes with stakeholder input and trade-off evaluation. The last one, the last graduate attribute which I want to focus is WA6. It's also very much critical for sustainable development, and you can see here in the statement itself, sustainable development has been mentioned, sustainable development. So when solving complex engineering problems, analyze and evaluate sustainable development impacts to society, economy, sustainability, health and safety, legal frameworks, and the environment. So it's very explicit. And this graduate attribute requires that we teach students to evaluate solutions for their impacts on society, economy, and environment. Integrate SDGs into problem solving and project assessment. Require analysis of health and safety, legal and regulatory compliance in engineering solutions. Encourage holistic impact assessments considering short-term and long-term effects. And we should use case studies where engineering decisions had significant societal or environmental consequences. And we should foster system thinking, linking technical decisions to broader sustainability outcomes. So in fact, all the 17 SDGs should be focused. Yeah, all of them should be focused in this case. So these are pretty much what I wanted to highlight from GAPC 4 about the knowledge profiles, complex engineering problem solving ranges, activities and attributes. Now, I want to highlight some of the notable enabling approaches to teaching sustainability. And they are based on research activities, which I'll show inshallah. So I'll try to highlight few things which are related to the core frameworks, like three pillars of social and economic sustainability. Also, triple bottom line, which I discussed earlier, people, planet, profit approach, this kind of business approach. Then some pedagogical approaches like project-based learning, company-based projects, and a framework which is conceive, design, implement, operate, CDIO. That's the acronym which I'll be using later. That framework. And of course, engineering education impacts will be that it should build system thinking, enhance ethical responsibility, and all of this should align with IES GAPC version 4. So the key message here in this section is that sustainability teaching is most effective when environmental, social, and economic dimensions are integrated into authentic, multidisciplinary, and outcome-driven learning. And this is related to outcome-based education. We know that. So let's delve into these strategies one by one. Starting with addressing the three pillars of sustainability. So the educators, engineering educators, should try to address all the three dimensions of sustainability: the social dimension, environmental dimension, and economic dimensions. And there are ways, like when we talk about environmental sustainability, the solutions should optimize use of energy, water, and materials, minimize emissions and life cycle pollution, protect ecosystems and biodiversity, prioritize regenerative and adaptive design. Yeah. So from engineering education perspective, we should train our students to apply life cycle analysis, eco audits, and renewable solutions to reduce environmental impacts. And some of the SDGs which can be addressed are 6, 7, 12, 13, 14, and 15. When we talk about EIA, environmental sustainability, we should, teach our students how to conduct environmental impact assessment. I'm sharing one flowchart here, can be modified. You should take it from a scholarly reference, that a detailed EI, which they're supposed to encounter after they graduate in the real field. So you can show them how they should be doing the screening, scoping, baseline study, impact prediction, mitigation and alternatives, environmental management plan, monitoring and audit, all these aspects. So we should teach them all these stages of EIA, environmental impact assessment. Talking about social sustainability, it should promote inclusion and accessibility in engineering solutions, protect health, safety, and human dignity, build community resilience through participatory design, and uphold ethics, equity, and cultural competence. Yeah. So from our engineering perspective, we should equip our students with social literacy to prioritize human values, stakeholder engagement, and justice in design. Yeah. And some of the SDGs which are aligned here are 3, 4, 5, 10, 11, and 16. Coming to the last dimension, and before I go there, I should also talk about the social impact assessment. And here I'm showing you one flowchart. So these are the different stages of social impact assessment: screening, scoping, impact assessment, mitigation measures, and monitoring and review. So it's very critical that our students learn when we are teaching, assigning them any project. We should require that you should have EIA, you should have SIA, and you are supposed to go through all these stages and document that in your final report. Now, talking about economic sustainability, it should prioritize long-term value through efficient, durable, and scalable designs, and foster sustainable entrepreneurship and innovation, promote circular economy, reuse, recycle, remanufacture, and ensure financial feasibility without compromising ethics and environment. So this, we should emphasize on this aspect, that they might be calculating different economic parameters, but that should consider ethics and also the environmental impacts. So the relevance, engineering relevance, would be our student should be able to evaluate life cycle costs, investment returns, and align business models with sustainability principles. And some of the aligned SDGs can be 8, 9, 11, and 12. And I have prepared a kind of flowchart here for economic analysis. Yeah, some of these are done in typical traditional economic analysis, but here we should focus on this aspect, sustainability evaluation. So in their project, they should also assess the social and environmental perspectives before taking final decision. Yeah, so it should be sustainability-based decision. The next notable approach which I want to highlight is the triple bottom line, the so-called PPP framework. PPP framework. So it was coined by John Elkington, the year 1994. And in this, framework, we have a foundational sustainability framework integrating three key dimensions: people, planet, profit. We can easily understand that people is related to the social dimension or social pillar of sustainability, planet is related to environmental, and profit is related to economic pillar. So these three forms the basis of environmental social governance. As its relevance to engineering would be, it will promote integrated solutions that benefit society, preserve the environment, and deliver long-term economic values. So according to this model, you can see a Venn diagram here. These three dimensions should combine, and then you have a kind of sustainable solutions where they meet, where they fulfill, the solution is fulfilling all these three dimensions: people, planet, and profit. That is sustainability. That is sustainable solution. So we should teach this to our students, and this model is widely recognized, quite popular. We can introduce this to our students. And next strategy which I want to discuss would be assigning problem-based learning. Some people also say project-based learning. Some people will combine both problem and project-based learning. So according to scholarly references, research results indicate that project-based learning increases awareness of sustainability among engineering students. Encourage students to engage with real-life interdisciplinary problems, fosters critical thinking and system-level understanding of sustainability, aligns with the complex engineering problem-solving framework, which we have in GAPC 4. Okay, so this PBL should be extensively used by the engineering faculties to teach sustainability. And another one, I found this in this UNICEF's document on sustainability in engineering education. I found this, that they are talking about assigning company-based projects. So the research insight would be that motivation increases when students work on company-based projects, as they perceive these learning situations as more authentic and exciting due to the presence of real client or customer. This is the essence of experiential learning, right? So student, if we give them this project, if we should have collaboration with the industries, the students should be engaged in real life projects, then they will see a tangible purpose and real world relevance. And stakeholder interaction enhances their responsibility and professionalism, encourage deeper engagement and long-term retention of skills. And finally, the last strategy which I want to discuss is CDIO framework. It's quite popular. It's basically conceive, design, implement, operate framework for teaching sustainable solutions in diverse engineering context. CDIO provides a structural approach. It emphasizes active project-based learning aligned with real-world challenges and SDGs. Enables progressive development of ethical and environmental responsibility, systems thinking, and life cycle awareness, interdisciplinary collaboration and innovation, all this stuff. So it's very important. Engineering education within the CDIO framework can integrate all the 17 SDGs by different stages. In different stages. In conceive stage, you can align project goals with SDGs 1 to 3, 5, 10, 16, 17, focusing on societal needs, inclusivity, and partnership. In the design stage, we can apply sustainable engineering principles for SDG 4, 6, 7, 9, 11. Education, clean water, clean energy, resilience, infrastructure, all this stuff. In the implement stage, we can ensure responsible production and innovation related to SDGs 8, 12, and 13, related to green jobs, circular economy, climate mitigation. And in operate stage, can maintain and improve systems for SDG 14 and 15, protecting ecosystems, managing resources sustainably. So all the 4 stages of CDIO can target different SDGs, and it will help us in teaching sustainability to engineering students. So the key message here is that CDIO offers a structural pathway for embedding SDGs into engineering curriculum, producing graduates ready to design and operate for sustainable future. There is one example I found from Tunisia. It will be there in the slide due to time crunch. I'm not going through this, but you can have a look of a case study here. So the last thing I would like to have is this call to action for engineering faculties that leverage GAPC version 4 as a roadmap for the sustainability transition in academia, link Washington Accord outcomes directly to SDG targets and indicators, embed 3 pillars of sustainability in courses, projects, and industry community partnerships, prepare engineers to serve people, protect the planet, and pursue meaningful purpose. Finally, let us educate engineers who can not only solve problems, but also sustain futures. Thank you very much for your patient hearing. I'd like to end here